Yeah, sorry.
Oh, yeah. Like that. Left, right, three of
Okay. I like to split our time between review for our area volume quiz, as well as starting to look at overall review for this semester. Let me go over the calendar so you can see what's coming up. So we are going to do some more area volume review, but there's one specific FRQ or AB FRQ topic that we haven't quite seen. It's an application of first theorem, and it's called this rate in, rate out type problem. So we'll talk about that today. On Monday and Tuesday, we're still going to do also this packet that you're picking up is your copy. So it's not the class set, it's your copy. We're going to be working towards preparing for 3 quizzes after the break. So the first quiz will be this table of values FRQ, which it's just one STEM problem, but it has a lot of applications that I want to have us explore. So we're going to work on that Monday and Tuesday. Wednesday is Senior Service Day. Thursday will be your quiz, your area volume quiz. It will be a minor grade. And then Friday, we'll continue reviewing this table of values FRQ that we're going to take after the break. So after the break, we'll continue reviewing for this specific type of problem, which will be a quiz grade the Wednesday after we get back. But we're also going to do review of things that we've taken in the past, like Riemann sums, differential equations. We're basically just doing review and helping you see the major types of FRQs, at least on the AB side, that you're most likely going to see on the AP exam. So I want us to just feel really comfortable with AB topics before next semester, because next semester we're going to devote the first 3 months, January through March, just with BC topics, and then we'll come back and review AB and BC topics when we begin AP review in March. Okay. So we'll take that quiz Wednesday after break, and then the Tuesday after will be familiar topics, Riemann sums, differential equations, and then this rate in, rate out, which we're going to talk about today. Okay, so we're going to talk about today won't happen until the second week after we get back from break. And then we're going to do 2 days of multiple choice review and multiple choice. There's just assortment of topics that we've covered over the course of the semester. And then the Friday before the last week will be a partner quiz. So it'll be, but you can choose which option that you have to let me know, at least the day before so I can prepare. Either you're going to take it individually, or you can choose your partner, or you can be in a group of 3. Okay. But there's different requirements within each of these. So if you're taking it individually, you'll all get the same test, but then if you're individual, you can decide to answer all 14 questions and then just eliminate the 5 that you don't want me to grade. And then I'll just grade the one that you want me to grade. And then if you're in a group of 2, obviously you're working together, but then you'll need to answer 11, but you'll get to omit 3. If you're working as a group, you each get your own quiz. It's the same version. You can work with each other, but you're both responsible for your own quiz. And then if you're in a group of 3, you'll need to answer 13, most of the questions, and then you get to omit 1. Okay. I encourage you guys to try all the problems, and then you omit. But if you don't omit, then I'm just going to grade the first 9 and omit the last 5. So you have to be the one to omit, otherwise I'm going to omit for you. Now, we do have, after the quiz next Thursday, there's 3 review quizzes. When we get to these quizzes, though, I'm going to buffer your grades with your homework grades. So this packet here, if you do all the assignments on time, this will count towards 50% of your first quiz grade. And then the second review packet will count 50% towards this quiz grade. And then the multiple choice packet will count 50% towards your last quiz. So, so for instance, assuming that you get 50 out of 50 for this packet, and then let's say you got 40 out of 50 on this, which is 80%, that's ends up being a 90. Okay, so you are going to get the buffering for your quiz grade. And then for the partner quiz, I'm going to be grading, even though it's multiple choice, I'm going to be grading on your work as well, which means that if you miss the problem, you can still earn partial credit, which is good. But that also means that if you circle the right answer, but then you don't show all the correct work, you may lose some points as well. So goes both ways. And then the final week, I don't really have anything. It's just Monday and Tuesday are still going to be full school days, but I'm just going to treat them like, if you, the multiple choice packet, if you don't have time to finish it by Friday, you can turn it in to me Monday, and it'll still be considered on time. So you have a choice. If you are having trouble finishing the packet by Friday, you can turn to me Monday. Or you could work on a Monday, give me Tuesday. As long as I have it, by Tuesday, that's good. I just need to have everything so I can put it into the grade book. So nothing new here, Monday, Tuesday, except I'm going to be still taking attendance. So, but I'm just going to treat it like a makeup recovery day, or if you need help sessions for a makeup day you want to take Wednesday through Friday. Wednesday through Friday are half days. These are not going to be counted towards your attendance. So you're only going to be showing up to your classes if you need to do any makeup or recovery. So that takes us to the end of first semester. Any questions? Oh, and then you'll get to use your calculators for all the remaining quizzes. Okay, so quiz on Thursday, you can use your use your calculator, and then all these you can use your calculator as well. Okay, no questions? All right, so let me start off by walking through this type of rate in, rate out problem, and then we'll use the second half of class to continue reviewing for your area volume quiz. Okay. You're going to need your calculators. I think we talked about this, how anytime you're involving a derivative, your units are going to change you're going to be including a rate. You're going to just keep on adding a rate. So if it's meters, then the derivative will be meters per second. If it's another derivative, meters per second squared. If you're taking the antiderivative, however, you're stripping away the rate because you're multiplying your units together. So meters per second will go up to meters, right? So okay, so that's just a review of that. Anytime we're doing a derivative, your units will change. If you're doing anything with antiderivative, your units also changes as well. Okay, so the rate at which people enter an amusement park on a given day is modeled by the function E of t. So yeah, so let's just assume that this is like Six Flags or something on a normal day. Your E of t will indicate the rate at which people are coming in, and normally what's going to happen is like a normal day, summer day, your rate of change, your rate of people entering into the park is going to be pretty high at the beginning of the day, right? Maybe at 9 a.m. you have 200 people per hour entering the park, right? But then by like 4 p.m., the rate at which people are entering the park is probably really low, right? Most people are probably have already been in the park and they're thinking about starting to leave. And then the rate at which people are leaving the amusement park is modeled by this L of t. We can imagine at the beginning of the day, not many people are leaving the park, right? It's probably a low number of people who are leaving the park. But then by 5 p.m., 6 p.m., we can imagine that rate is going to be increasing, right? Most people are getting ready to go home and leaving the park. So E of t is going to start high and end low. L of t, the rate at which people leaving, is going to start low and end high. Okay, so that's the pattern that we can expect. Okay, both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. These functions are valid for 9 to 23, so 9 a.m. to 11 p.m. basically, during which the park is open. At time t equals 9, there are no people in the park. And so part A says how many people have entered the park by 5 p.m. So we know that this is dealing with E of t. We're basically having to accumulate. We know this is in terms of people per hour. So what do you think we can do if we want to find the total number of people who've entered in the park? Take the what? Right. We want to accumulate the rate over the course of the day. So what feature can we use? Take the what? Not the derivative, but integral, right? So integral will allow us to accumulate the rate. Like if we know that, okay, let's just say we have a constant 300 people per hour coming in. If we take the integral, then we can accumulate that rate over the course of our time period. But let's just start by entering into our calculator because we're going to be calling these functions, and it's easier if we're not having to type it in every single time that we want to use it. So under E of t, I'll do alpha y equals just to get that numerator math print numerator denominator. And I'm just going to type in my E of t. So 15,600 numerator. And then your denominator, even though on paper is in terms of t, you're always using x variable in your calculator. $160, yeah. Okay, and then go to y sub 2 and go ahead and enter in our L of t. We're going to need that a little bit later. So L of t, another fraction here. Again, we're always using variable x in our calculator. Okay, go do second mode, go back to your home screen. So part A, how many people have entered in the park? We want to accumulate the time range between 9 and 17. 17 represents the end time period, 5 p.m. So integral from 9 to 17 of E of t. Okay. And the unit should make sense as well. E of t is in terms of people per hour. Time is in terms of hours. You know that when we go through this process, people per hour is going to turn into the number of people, and that's what we want, right? We're trying to count the number of people who've entered in the park. So I'll do math 9 from 9 to 17. Alpha trace y1. Y1 is holding my E of t function. So we can estimate 6,004 people have entered in the park between when the park opens at 9 a.m. to 5 p.m. So this isn't necessarily the number of people who are in the park at 5 p.m. We're just counting the number of people who've entered in through the gates between 9 and 5 p.m. Okay, part B, the price of admission in the park is $15 until 5 p.m. But then after 5 p.m., the price of admission drops down to $11 per per person. So how much money have been collected from admissions on the park on a given day? So we can figure out how many people have entered in the park by 5 p.m., multiply that number of people by $15. And then after 5 p.m., we can find the number of people who've entered in the park and then charge each of them $11, and then we can figure out the revenue. So we can just take 15 times the 6,004, which I'm just going to write the integral notation again. How can we represent the number of people who've entered in the park from 5 p.m. to closing? Yep, 17 to 23, E of t. And whatever this gets back to us is the number of people who've entered the park, and we'll charge each of them $11. Yeah, if you didn't round this and if you left a decimal, then your number may be a little bit off, but I think we're gonna be around the same value, so that's fine. Okay, so far not too bad. But part C, we have some things to talk about here. Any questions so far, A or B? Okay, part C says let h of t represent the integral of e of x minus L of x between 9 and 23. Okay. The value of h of 17 to the nearest whole number is 3725. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of this amusement park. So let me write h of t out. So basically, this is taking the integral of e of t and then subtracting the integral of L of t between 9 and some value, okay? And it says the value of h of 17 is 3725. Let's just put in 17 just to see what that looks like. So that means h of 17 would be the integral from 9 to 17 of e of x minus L of x. Now, this is also, that L of x is also getting its integral. I just want to separate them just to make it maybe a little bit easier to think about in terms of what it means. So what do you think this means here? The integral from 9 to 17 of e of x. This means some people who have entered in the park in that time period, and then subtract out the number of people who've left the park. So what do you think this h of 17 means? Because they say that it's 3725. People who are left in the park, right? You count all people who come in through the doors, coming through the gates, and then subtract all people who've left, and then what's left over is number of people who are left in the park. Okay, so we know that h of 17 is equal to 3725, means 3,725 people remaining in the park at 5 p.m. Now, they say find the value of h prime of 17. Okay, let's figure out what h prime of t looks like first. So h prime of t means I'm asking for the derivative of this, right? So I'm going to write out what I want. I want the derivative of this expression. Okay, look at this notation here. What does this remind you of? This is that theorem, right? The second theorem. What happens with this derivative integral feature here? What's going to happen here? Yeah, they're canceled out, and I'm just going to replace the x with what? So h prime is just e of t minus L of t. Okay. So going further is asking, what is h prime of 17? It says find the value of h prime of 17. Okay, so let's do that. So h prime of 17 would be e of 17 minus L of 17. So let's talk about what this means here. So we know E of t is the rate at which people are entering in the park. L of t is the rate at which people are leaving the park. What do you think E of 17 means? Well, rate at which people are entering in the park at what time? 5 p.m. What do you expect this number to be? Low number, right? Well, lower, right? Probably not as high as early in the day. So maybe like a smaller number. What do you think L of 17 means? Rate at which people are leaving the park. So what would you expect E of 17 and L of 17 to produce? A negative, right? So we expect L of 17 to be a greater number, assuming this is like a normal day of operation, and there's no like special event going on in the evening. We expect this to normally be a negative number, right? So that's what we're expecting. So let's try putting that in the calculator. So we know that E of t is held under y1. We know L of t is held under y2. So I'm going to do alpha trace y1 parentheses 17 minus alpha trace y2 parentheses 17. And we should be getting a negative number if you do math decimal negative 380. So let's write that number down. H prime of 17. And what's our unit going to be? Yeah, E of t and L of t is a rate, so we know this is people per hour. So how would you interpret this? What does that number mean? Yeah, so we can say the number of people in the park is decreasing by 300 people per hour at 5 p.m. The park population is shrinking by this number, that's 380 people per hour, because more people are leaving the park, and that park size is decreasing. Part D. Okay, at what time does the model predict the number of people in the park is at a maximum? So if you had to guess, I mean, just imagine a normal day at an amusement park. Around what time would you expect the park to be at its maximum size? Yeah, somewhere I would say mid-afternoon, right? Mid-afternoon when people are still coming in, but then not as many people are leaving yet. So you imagine mid-afternoon to be when the park is at its maximum, right? If it's in the morning, people are still coming in. If it's in the evening, people are leaving. So somewhere in that maximum. So we're going to use this model to kind of help us figure out where that maximum is going to be. We're basically trying to figure out when are these values going to meet, right? Because you can imagine E of t is going to start high, right? And L of t is going to start low. And they're going to do this, right, over the course of the day. And the maximum is going to occur when they meet at some point, right? Because when they meet, that means that's the maximum size. After that, L of t will be greater than E of t, and then this park size will begin to shrink, right? So the idea is that we know that our maximum size is going to occur when H prime is equal to what? 0, right? When H prime is equal to 0, when E of t and L of t are equal to each other, that's when park is going to reach its maximum, because after that, park size is going to start decreasing. When L of t gets greater than E of t, then you have more people leaving than coming in. So we're looking to see when is E of t equal to L of t, or when E of t minus L of t is equal to 0. Okay. So here is our strategy to help us figure out the time when this is going to occur. I mean, we could set E of t equal to L of t, but you can see that these equations are tough to solve by hand. We're going to make the calculator do it. So what we're going to do is we're going to, in the most efficient way, is we want to graph this function. Or graph the combination of this expression, and then simply look for the x-intercept. Because whatever t-value causes this to be equal to 0, then that'll be the time when we're going to reach that maximum size. So, okay, so we're going to look for what this graph looks like, and just simply, the graph looks something like this. We're simply looking for the x-intercept. So I'm going to create a y sub 3 where I want to just do a y sub 1 minus y sub 2. I would rather not have to retype everything over again. So under y sub 3, but I don't want to erase this. So I'm going to say alpha trace y1 minus alpha trace y2. I want to graph this, but I don't want to have to look at all these other graphs as well. So what you can do is you can go to the equal sign, and then you can unhighlight it by hitting enter. If you hit enter at the equal sign, it will still remain in the calculator, but it will not graph for you. You don't have to look at competing graphs to figure out what you're looking at. So I'm just going to do y1 minus y2. But my window may not be ready for it. If you look at your numerator, these are all in the thousands. Right? So these are going to be pretty high y values here. So I'm going to make an estimation here. So under my window, I'm going to make an adjustment to x min, x max, and y min, y max. If you look at your domain, we're looking at between 9 and 23, right? So we only need to worry about, we're looking at some time between 9 a.m. and 11 p.m. Now for your y min, y max, I'm just going to do an estimation here. My functions are all in the thousands. So I'm just going to try this out. What if I go from negative 1,000 to 1,000, just so I can maybe have my y values wide enough where I can maybe hopefully see a curve. And again, if you're ever playing with your window, you're only playing with your x min, x max, and y min, y max. Okay, hit graph. Let's see what happens. So that's what I'm looking for here. I'm looking for that x-intercept where my E of t minus L of t is going to zero out. Because after that, my park size is going to start decreasing. So if you do alpha trace 0, pick a point to the left of the x-intercept, hit enter. Pick a point to the right of the x-intercept, hit enter again. And we get 15.79. That's around 3 p.m. So that's what we expect, right? We expect it makes sense that for this day, our power population is going to reach its maximum at around that time. So part D. It's not asking for the actual number of people. If it were, we would just be able to plug it into this H of t formula here. But you're asking only for the time at which that's going to happen.
Didn't you also do like intersect and find out where?
Yes, yeah, that's good. We can also do intersect. The reason that I'm not, to your point here, we can graph E of t and graph L of t and see where they intersect. I think the only issue there is if you're doing that, you're going to have to adjust your window to figure out that intersection. The reason that we encourage this way is because then you can just always search along the x-intercept. You don't have to search all over the graph for the intersection. So this is the preferred way that I would suggest, but if you want to do it using intersection, you can. You just have to adjust the window so you can actually find that point yourself. But I think this is the easier way, but obviously that's your decision as well. Okay, I also want to go over number 3. This is also an important problem, but I'd like to maybe just save this for Monday instead, and have us just do a daily review of our upcoming quiz area volume. So if you can turn to page 3 in your quiz review packet, and let's just see if we can get through page 3. So go ahead and graph your two functions. The important thing here is figuring out these intersections so that you can use them for your area bounds. Zoom box, zoom one will help you focus in on that region. So look for that intersecting point and look for this intersecting point. Pick a point near the first intersection. Point 178 is our X value. Pick a point near your second intersection. Ends up being exactly 1. So area of region S is just top minus bottom. Top is the f of x, bottom is the g of x. Okay, area of region R. Notice that region R has a different top function since this g of x is now at the top and then your f of x is now at the bottom here. So that's going to extend from the y-axis, which is x value 0, so 0 to 0 to 0.178, which is flipping the top and bottom function here. Just make sure that you protect the bottom function with a set of parentheses since there's multiple terms there. You do want to make sure that the negative gets distributed through. And plug that into your calculator. Part C, find the volume of the solid generated when S, that's this larger region here, is rotated about the horizontal line y equals -1. rotation. So if you're rotating around the line, you know you're always deciding between disk or washer method. So what do you expect? Washer, yeah. There's obviously a gap. And if it was touching, it would still be washer. Remember, it's got to be touching a flat surface if we want to be a disk method. It's touching, but if it's a curved surface, it is still a washer method. Draw your true radius. Okay, so the top of my big radius is sitting on the sine graph. Minus my bottom, which is at -1. Careful, there's two negatives here, so you got to keep track of both negatives. Ends up being minus -1, which will end up being +1. Small radius, the top of small radius is sitting on the other graph, the 4 to the -x. The bottom is sitting also at the -1. Which is also positive, +1. Okay, so we know it's going to be Washer method. So big radius squared minus little radius squared. Again, make sure that both your big and little radius are getting their own exponent squared. And then your integral is just from region S that we found here from 0.178 to 1. Oh, I forgot, there's a pi in front as well because it's rotation, circle related. So I'm just going to type everything in without the pi and then add pi. It wasn't able to convert to a fraction for me, so I'm going to just round to 3 decimal places. Okay, enclosed region R is the base of a solid. So now we're thinking in terms of volume of cross section. We're now imagining region R is a flat surface, and we're going to be building these shapes that's going to come out of the page. But first is understanding which direction to draw our base length. So which direction is this? Parallel to the y-axis. Vertical, yeah. So make sure you spend time just making sure that you're confident of the orientation of your base length. So it's going to be vertical. So let's find that base length expression. Top minus bottom. So top is at the 4 to -x. Bottom, protect that with a set of parentheses. Parentheses minus parentheses 1/4 plus sine pi x. So remember with cross section, you're kind of building everything one dimension at a time. So we have our one-dimensional base length, which is this expression. And then moving on to our area, isosceles right triangle with leg on the base. We know all the formulas has a base squared, just have to worry about the difference in the coefficient. And the formula is 1/2 base squared. So we'll insert that into that base. Then we have two-dimensional information here. And now the third dimension is putting the integral and dx around it with the bounds. Again, make sure that you're always in radian mode, especially if trig is involved. Okay, let's move into page 4. I'm going to be checking your homework for. I'll be checking just page 3 and 4. I think we can get through most, if not all of it, but before the end of class. So go to page 4 and see if you can start setting it up. Okay, does anybody still need to look at page 3? Okay, pay attention to your boundaries here. The X and Y axes are just in the background. They're just there to help you provide some perspective. But the boundary we're looking at is natural log of 4 minus x. That's the curve. Y equals x equals -1, and then the x-axis. So basically, we're not going to involve the y-axis at all. It is just there as reference. I see some students, they would look at the axis and they would try to break everything up, thinking that that's another boundary to worry about. But I'm just drawing the x and y axis as reference points for your for the rest of your graph. So yeah, basically you're ignoring the y-axis. It's not going to be a boundary here. Okay, so here's x equals -1. Here is the natural log of 4 minus x. Here's the x-axis. So our shader region is here. Okay. We're revolving about the line x equals -1. So that's here. Okay. Look at that location between the axis and the shader region. What does this tell you here? This method, yeah. It's dotted line up against a flat surface. There is no gap. Now this would be this method. But our rectangle, our radius is going to come out what? Horizontal, which means the equations need to be rewritten. These natural log of 4 minus x, that equation is not going to be suitable for a right minus left. So we got to solve for x in terms of y here. So we know our radius is right minus left. Right endpoint is sitting on the 4 minus e to the y. The left endpoint is sitting on the -1, so careful, minus the -1, that'll end up being positive. And then we're stacking these horizontal circular discs, the lowest y value to highest y value. Lowest y value is just going to be 0. The highest y value is going to be wherever that order pair is. So there's no need to do any messiness with your graph. You're just looking for that y value at that point. So just plug -1 into the function to get the y value, which will be the highest of the shaded region. Right, so my order pair is if I plug -1 into the function, I get natural log of 5. So my bound is simply from 0 to natural log of 5. Or you do a decimal version of that. On paper, you're going to use variable y, but in your calculator, you use x. Leave pi out of it. Okay, your homework, just pages 3 and 4. I'll check that Monday, and we'll continue reviewing and look at FRQs as well.
What we did, that's how they like. Now they're like, 1.2.
Have a nice weekend, guys.
Oh, you like Calc? You like that?
Bye, thank you.
Yeah, it's kind of hard to.
Thank you. Good weekend. Bye.
Yeah, what's that?
Good weekend. Thank you.